All right, well, welcome to Geometry Section 1.5. This is all about angle measures. So before we start up with angle measures, let's talk about, well, what is an angle, the definition of an angle. Well, an angle is two rays that share a common endpoint. So for example, here we have ray BA and we have ray BC. They share a common endpoint B, that's an angle. The vertex of the angle is the point that the two rays meet at. The sides of the angle are the rays themselves. The angle has an interior, everything inside in between the two rays, and an exterior, which is everything outside the two rays. Naming angles. Everything else has names, why not angles? There's several different ways to name angles. First, you could aim this angle right here, you could name it angle N. Name it by its vertex. You could name it by its rays, M and P, or P and M. Or you could name it by its interior. So this, we would put a small number or letter inside the angle. That would be the interior of the angle. We'd call this angle 1. All right. So just like segments, angles have names, but they also have measures. So here's a tool that we use for measuring an angle. It's I kind of drew a rough picture over here. It's called a protractor. The protractor has numbers marked on it. They start at 0 and they go over to 180. And when we measure the angle, basically we're looking at where the two rays go through the protractor, and it's how far it is from one number to the next. For example, this one here goes from 45 to 180. That's a difference. The turn, if I were to be looking in this direction and I turn the ray around to look in this direction, the turn goes from 45 degrees to 80 degrees, so that's a 135 degree turn. Right? So when you're using the protractor will have a center which you place right on the vertex, and then you'll place one of the rays, well, both the rays just go through the protractor, but it's best to place one that goes through either the 180 or through the 0, so you can easily calculate how big the turn is. Beware, there will be numbers on the outside of the protractor, but there will also be numbers on the inside of the protractor, and they go in opposite directions. So on the outside, it goes from 0 to 180, but on the inside, it'll go from 0 to 180 in the opposite direction. So when you're checking, oh, this goes from 45 to 180, make sure that you're using two numbers that are either both on the outside or both on the inside. Don't use one number from the outside and another number from the inside. That'll get things mixed up. All right. By the way, talking about angle measures, just like when we were dealing with segments, there's a special notation for it. If this is angle 1, we put a little m out front, and that means measure of angle 1. So measure of angle 1 equals 135 degrees. All right, we have several different angle types. We have acute angles, which are between 0 and 90 degrees. Right angles, which are exactly 90 degrees, and we have a little symbol for that in the diagram. Obtuse angles, which are between 90 and 180, and straight angles, which are just a straight line, completely open. Just like segments, we have congruent angles. And just like segments, they're angles that have the same measure. So we would say here that angle A, we have that congruent symbol, angle B. Angle A is congruent to angle B, and that means that the measure of, that's with a little m out front, the measure of angle A is equal to the measure of angle B. So these two statements are pretty much interchangeable. They kind of mean the same thing. All right, we also have, again, this is a lot of similarities with the segment section, but we have a thing called angle addition. So just like the segments, the parts of an angle add up to the whole, just like the parts of a segment add up to the whole. So here, I've got two smaller angles, a 20-degree angle and a 19-degree angle, and together they form this larger angle, ABD. Notice it would be a bad idea to call this angle B, just with the vertex, because they're actually, the two small angles and the big angle all share the same vertex. So we want to specify using the ray name ABD, wrapping around. So angle ABD, the measure of ABD, is the small 19 and 20 degree angles put together for a total of 39 degrees. And you could also use this in reverse. Say you knew the big angle was 39, you knew that one was 20, you would subtract and find out that that was 19. Alrighty. We also have angle addition with algebra. We did this with segment addition, and we're going to see this pop up again with angle addition. So I might have a large angle here, and I have two smaller angles, and their measures aren't numbers, but they're represented with expressions. So I know this large angle here is a straight angle. It's 180 degrees. So the two small angles, 10x minus 5 and 4x plus 3, they are going to add up to 180. So these two small measures add up to 180. I do the algebra. I get x equals 13. And then I go back, and I'll plug in the 13 for x into both of the expressions and find out that the large angle is 125 degrees and the smaller angle is 55 degrees. Now, watch out. A really common mistake here is that students don't pay attention to what it is they're being asked to find. And, there's no instructions here at all. Guess I should have added that. Anyways, sometimes you might be asked to find x. In that case, x equals, and you're done. But sometimes you might be asked to go a step further and find the actual angle measures, which is where you have to do this substitution step. So make sure you know what it is that you're being asked to do. All right, so I think that pretty much wraps things up. We know what an angle is. We know how to name it. We know how to measure it. We know how to combine angle measures using angle addition, and we've seen how to use angle addition along with algebra, and we've talked about congruent angles just a little bit. So I think you're ready to go ahead and start doing some problems.